Good morning, everyone. As you all know, this is Ramadevi from Mechanical. Today, I had to present on topic galvanic cell. Here it is. Galvanic cell or voltaic cell was invented by Alessandro Volta and Luigi Galvani respectively in 1800s. Now let us see what is an voltaic cell. Electrochemical cell used to convert a chemical energy into electrical energy. Here we use the word electrochemical cell. Electrochemical cell means which is used to convert the chemical energy into electrical energy or electrical energy into a chemical energy. Electrochemical cells are two types. One is a galvanic or voltaic cell which converts the chemical energy into electrical energy. Another one is a electrolytic cell which converts the chemical electrical energy into a chemical energy. Let us see the examples for galvanic cell. One flashlight or battery and powder calculators. Mode of half cell is one part of the voltaic cell where oxidize or reductions takes place. To understand the working of voltaic cell, take example of Daniell cell. Galvanic cell or voltaic cell consists of two half cells. One is left half cell, another one is a right half cells, which are connected to a salt bridge. Let us see what is a left half cell. Left half cell consists of zinc metal strips. Dipped in a 1 molar of ZnSO4 solution, it is an anode. Another one is a right half cell. Right half cell contains copper metal strips, which is dipped in the 1 molar of CuSO4 solutions. It is a cathode. This is the arrangement of the voltaic cell. Now let us see briefly about the galvanic cell. A galvanic cell or voltaic cell is an electrochemical cell. That means chemical energy that converts the chemical energy to electrical energy by spontaneous redox reactions. Means here reductions and oxidations both are takes place within the cell. It generally consists of two different metals connected by a salt bridge or individual half cells separated by a porous membrane. Here, salt bridge consists of agar-agar powder and saturated KCls. The role of the salt bridge is which allows the ions to pass through it. And it consists of two half cells as shown in the figure. The half cell on left contains a zinc metal electrode dipped in the ZnSO4 solution. Another half cell on right consists a copper metal electrode dipped in the CuSO4 solutions. The two half cells are joined by a salt bridge which prevents the mechanical mixing of the solutions. When zinc rod and copper metals are connected by a metallic wire externally, then the reactions takes place. Means here Zn means zinc have a greater tendency to ionize in a salt solutions which produces a Zn2 plus ions are two electrons. These released two electrons are passes through the metal wire and reaches to a Cu. Here Cu2 minus converts into a Cu with the help of two electrons gained by the zinc. Then here the electrode reactions takes place. Let us see what the electrode reactions takes place. At anode, oxidations of reactions takes place. Means here the loss of electrons takes place. Zinc gives rise to Zn2 plus 2 electrons. Here the E value is minus 0.77 volts. At cathode, reductions takes place. Means the gain of electrons takes place. Cu2 plus 2 electrons gives rise to Cu. Here the value of E is 0.37 volts. Now let us see the net reactions. Zn plus Cu2 plus gives rise to Zn2 plus Cu. The following observations are made. Let us see the observations which was made in the galvanic cell. Electric current passes through the zinc electrode to the copper electrode through external circuit. Zinc rod loses its masses while copper rod gains. Means zinc loses its electrons. Means its masses decreases. This and then copper wire gains its masses. Means this copper gains the electrons which was released from the zinc. So here copper gains its masses. And then another observation is concentrations of ZnSO4 solutions increases while concentration of copper sulfate solution decreases. Solution in both the compartments remains electrically neutral. Now let us see about the electromotive forces. The flow of electrons from one anode to the another anode is due to the difference in the electrode potentials. The difference in electrode potentials which causes the flow of current from the electrode to the another electrode is called electromotive forces. Let us see the equations. E cell is equals to E oxidation plus E reductions, or another way we call it as E cell is equals to E cathode minus E electrode. Now let us see the representation. Just once see the representations of the galvanic cell. Here it is. Then the half cell reaction corresponds oxidations. Zinc gives rise to Zn2 plus 2 electrons. Here E oxidation is minus 0.77 volts. The electrode is oxidation electrode and the potential is oxidation potential, which represented as electrode oxidation or electrode left half cell or electrode E anion or E anode. The half cell reactions correspond reductions. Cu2 plus 2 electrons gives rise to Cu. Here E value is 0.34 volts. The electrode is called reduction electrode and the potential is reduction potential, which represented as E reduction or E right half cell or E cathode. Then EMF of the cell is equals to the sum of the oxidation potentials and reduction potentials. It is also expressed as reduction potentials of the right hand side minus reduction potentials of the left hand side electrode. Now let us see the electromotive forces of the galvanic cell. E cell is equals to E naught RHS minus E naught LHS. We know the value of the right hand side half cell is minus 0.77 and the right half cell is plus 0.34. Here these are placed in the equation. Let us see. E cell is equals to 0.34 minus of minus 0.77 and the value of the electromotive force is 1.1 volts. At first I say that the word electrochemical cells means which converts the electrical energy into a chemical energy or chemical energy into a electrical energy. This is two types. One is a galvanic, another one is a electrolytic. Now let us see the comparison of the galvanic and electrolytic cells. Galvanic cells which produces a electric current and it is a spontaneous redox reactions, means both the oxidation and reductions takes place and here electric conditions takes place. Electricity conditions takes place. And then electrolytic needs a power source, means here in the electrolytic cell electricity converts us into a chemical energy, means electric energy converted into a chemical energy. So here we need a power source and it is a non-spontaneous redox reactions and here it is a electrolysis takes place. Thank you sir, thank you for giving me this wonderful opportunity.